but this topic is very important. I still do apply this one in my research. Okay, still remain the same. All right, now let's do supervised learning project, and you can use this as your project next semester. Let's proceed. Okay, type of supervised learning project. All right, you got classification like prediction cat and dog. You predict the category, whether it is a cat or a dog, whether it is epilepsy or not, approved or not approved, whether it is running behavior or walking behavior, you know, whether it is a human face or not, a car or not, or lorry, and so all those things. And you can classify, you can have label about 2, 3, 4, 5, 10, even 1,000. Okay. Just now at the beginning of the slide we have 1,000 label, so they have 1,000 category, 1,000 to be classified. In this case we have cat and dog, so only 2 need to be classified. If you got 1,000, you need 1,000 label, 1,000 things you need to classify. All right, the second one is regression. It's predict quantity, prediction of age based on height, weight, and healthy, and so on. Prediction of stock, prediction of pandemic, and so on. So in this case, you use regression. Okay, and anomaly detection. This is another one. Okay, predict money with withdrawal anomalies or any anomalies, breast cancer anomalies, EEG anomalies, and other thing. Okay, as long some behavior anomalies. Okay, anomaly. So as long there is something weird, you can detect it. Okay, so this is another kind of project you can done. Okay, and clustering. Clustering is a bit different. Whereas these three basically is supervised learning, clustering is a bit unsupervised learning. So you don't do this project. Is beyond of our scope. Okay, clustering is beyond of our scope. But basically clustering is, you got a picture, you don't know the label, that's it. You have data but you don't know the label. You have to sort it out yourself. Macam main puzzle. Puzzle untuk awan you kumpulkan satu. You tengok puzzle tu like blue color, you find all the puzzle, you collect all the blue color and you group it together. So you name it is sky. That's clustering. They don't have label yet. So this is raw data. When you're collecting your EEG, any EEG, then you don't know what label is that. You do have to find out. How do you find out the EEG label? You see the doctor, the expert. This kind of picture, what do you conclude? And then the doctor said, oh, this is normal. You said normal. So it's manual. You do the labeling yourself. The data is not labeled yet. But just now we have a bank. The data is already there. And label is already there, whether it's approved or not approved. And the dog, you got a picture of dog and you put all together in one folder named dog. So it's labeled, already labeled. Now you got the pictures in your gallery handphone, but no labels. Everything is there. Rojak. Then you have to sort out. Yang mana main bola, yang mana ni. So that's clustering. Okay, that's this kind of project. So basically, you supervised learning 1, 2, 3. This is unsupervised, different. Okay, out of our scope. Your work basically 1, 2, 3. So in car prediction, driving self-driving car, classification can be because you're going to predict in front of the car. You got a camera, you got camera in front of the car, you're going to predict the road, the stone, the signboard, people, car in front of the car. Okay, so your label going to be rock, road, human, animal, signboard, anything. So that's classification. Okay. And regression, driving car, is about which turn to take in and so on. Okay. Anomaly in driving car. Anomaly in front of your camera, in front of the car. Is there any anomaly detection? Anomaly means that you got some kind of rock in front of there, but quite different. It may be not rock, maybe other things. Okay, just like a rock, but it's not a rock. That's anomaly detection. Okay, and the car and the ball bouncing it's suddenly on the road and something like that. Okay. All right. In process flow of developing the supervised learning project, basically you got this step. First, you get problem definition, the process flow of developing a supervised learning project. Data preparation, develop model, train, and increase. So if you do the project on your next semester, you can have this chapter. One chapter, this one, second chapter, this one, third chapter, this one, fourth chapter, this one, last chapter is assessing the performance, chapter number 5. Okay, so you can have your dissertation on your project next semester based on this chapter. First is problem definition. Basically, problem definition is understanding the problem. What kind of project do you going to develop? Which is classification dog and cat? Or other thing? Which is regression? It is detect anomaly? So I think better this one no lah, okay? Because it's out of scope, okay? All right. Okay. Problem definition. Just now, like a dog just now. You want to classify dog and cat or specific type of dogs, or how many dogs you want to classify? 10, 2, 3, 20. Like just now, you got a patient therapy. I don't know much about that. I need to understanding the domain. Then I can know what's the problem. And when I read about therapy, okay, so I know, then I can do classification. Then I can do label. Okay, then after that I can think about collecting the data, collecting the sample. Okay, so if you have just now I said data set is you have a lot of data set out there in the internet, but in your project probably you can collect on your own. Okay, collect on your own. 30 sample, 30 student, 20 student, how many are there? Collect all those things and label it. Okay, so this data must be collect and must be got features and must be labeled. Okay, because we do on classification. So the data you prepare must be got features, identify the features, and identify the label. Okay, features and label are very important. And also, you think about how many classes you want to have, how many label you want to have. Okay, so this is also sort of problem definition, the domain. And you have to be clear on this, so the rest will be easier. If you clear on this problem definition, then it will easy for you for data preparation, what and collect data set. Once you have the data, basically, you clean it, you modify it, so it's suitable. Okay, and it's fair enough. Okay, and when you data preparation, when you say you have a cat and dog, you have to check every pictures. All are cat and dogs. If you got a picture of monkey, then it is a noise, and delete all pictures of monkey or others, because that's not one that we're gonna train the machine. Data is very important in supervised learning project. If you have sufficient data, good data, the machine will learn sufficiently. If your data collected is not really represent the domain of the problem, classification and label, so the machine won't learn enough. It might be predict, okay, predict whether it is a cat or dog wrongly, and the accuracy bit down. Okay. Now the third one is a develop model. So in this case, you're gonna use a neural network. Forget about k nearest neighbor as support vector, k mean decision tree, and don't worry about this. Okay. So I guess this one gonna be
Prof,
yeah.
for the developing of the models, that one we just use the models yang memang sedia ada, then tak perlu create another model kan?
It depends. Kalau nak make it easier, you just use the existing model,
Okay.
but you have to pick carefully lah. If you develop cats and dogs, two label,
Okay.
kan?
Okay.
You're gonna
Okay.
find out there a model that classify only two things, and you have to look at the input data apa dia, domain dia apa dia. Kalau similar cat and dogs, you can use it. Take the model as it is and just input your new data set.
Oh, okay.
Otherwise, you just start by scratch.
Okay.
Main neural network. It depends on you how many neuron you nak letak.
Prof, I want to ask about the this supervised learning project. Is that related with the prosthetic that we use? No, for example, that like Japan use prosthetic like AFO. Is that similar? They try to propose the system yang lebih kurang.
Prosthetic apa? Explain more on that.
So, macam I tengok prosthetic from the Japan. So
prosthetic is what? Prosthetic is
prosthetic alat bantuan. Alat bantuan. Terapi bantuan.
Oh, yang kaki palsu tu ke?
Ya, ya.
Okay, see, that's a new domain to me. So, okay, and then go on.
Because it's look interesting. So is that we learn about supervised learning project ini ada kaitan dengan yang how we create the item.
Yes. As long as learning is there. Macam prosthetic, I think, but I think logically, you nak pasang prosthetic equipment tu depends on the person kan.
Ya, Prof.
You
Because
kena ukur dia punya, kalau kata potong kaki, you kena ukur lilit kaki dia.
Yes,
apa lagi?
correct.
Besar dia, size dia, panjang dia, tinggi dia, you kena data tu semua kan?
Yeah, Prof. Actually, in Malaysia, we are using we create the AFO. We do manually. So we use the spleen and.
AFO, what is that? AFO?
AFO is.
What's in there?
AFO is the dia macam kaki plastik yang kita bentukkan ikut shape patient tu. Dia macam plastik lah, kasut plastik.
How do you decide? How do you mold that kaki tu? You perlu data apa?
Kita akan masukkan dia pada splinting pan. So pan tu dia akan dipanaskan.
No, it's okay. But how you decide the pattern size of that mold to some specific person? What do you faham tak maksud saya? You nak buat kaki tu, you kena tahu person tu kan?
Yes, betul. Kita tengok kondisi klien tu. Kita
yes, apa yang you ukur sebelum you buat tu? Apa yang you nak data sebelum you mold the kaki plastik tu?
Kita tengok klien punya condition. So
apa dia?
Macam contoh, for example, dia ada stroke. For example, stroke. So dia ada muscle weakness on dia punya kaki. So dia perlukan AFO. So kita ambil ukuran splinting. Splinting tu macam plastik lah. And then kita ukurkan pada dia punya kaki, and then kita akan moldkan daripada dia punya splinting pan, and then kita akan put the splint on dia leg.
Okay, sekarang I think mold tu ada banyak bentuk, banyak kategori kan?
Betul.
So, okay, ada berapa patient yang you buat mold tu? Banyak kan?
Ya, banyak.
Ada data kan?
Ada data.
Data tu mungkin boleh jadi data set.
Oh, okay.
Because that patient, everyone has each mold lah. And at the end of the day, mold tu pun I think about 100 types kan? 100 or 200. Tak lah, setiap seorang unik kan?
Dia akan depend, dia kena study more detail lagi mengenai klien punya condition tu.
That you can use this one. And in this case, in your case just now, I'm trying to problem definition because I'm asking about what is protestic, what is mode, what is AFT. So I am trying to understanding the problem. You see?
Okay.
When I understanding because this is your domain, I'm not my domain, so I'm trying to understand the problem. Then I can decide whether it is classification, ada data set apa, features apa, label apa. It is after I study ni, it is possible to do supervised learning project, and I said yes, and I have to need to collect the data. So this is important lah. Problem definition is important.
Okay.
Macam abjad A, B, C tadi is not really like straightforward.
Because Prof, that one dia already one company dia dah buat tahu mengenai buku tu, and then dia ambil di China. So di China dah setkan untuk dia. So if the kids tekan one button, so that button dah set up button dah untuk menyanyikan lagu macam tu.
Okay. Let's put this way. Kalau student tu tulis atas kertas huruf A, sistem akan predict this is A. That's I think is a supervised learning project because every student, every pelajar dia akan tulis herod-perod and differently. That herod-perod to become my data set. That's good a supervised learning project. Kalau straightforward, okay, faham tak? Kalau project tu just simply ada huruf, dia tekan huruf tu bunyi A, that's straightforward thing. If if press this, sound this. If press this, sound B. If this, please sound this.
Okay.
Kalau you let the student, ada 10 orang, tulis atas kertas, and then the system be able S-A-Y-A. You telah menulis S-A-Y-A. Ataupun macam ni. Software tu cakap, tulis perkataan saya. Pelajar tu pun tulis S-A-Y-A. Nanti komputer be able to recognize the one you tulis itu adalah S, the one you tulis itu adalah A, yang ditulis itu adalah Y dan A, dan jawapan adalah betul. The data set here mean basically S, because you got say 1 million people. Everyone wrote differently. You have to collect all those data set. So the computer be able to learn all type of S, sengit, herod, perod. Kadang tak boleh baca, kalau tulisan doktor memang tak boleh baca. Kalau tulisan doktor, it's bit difficult of the data set because memang susah. Okay, so this depend on the problem definition.
Okay, understand. Thank you, Prof.
Okay. That's supervised learning project. You know, the first thing important is problem definition. You have to understand the domain and it suit to the supervised project based on the data set, based on the intelligence of the thing. Because macam student tu tulis, kita kena ada intelligence tau, nak tahu S-A-Y-A. Because tulisan dia semua lain-lain. Sengit. Kalau tulisan dia macam dekat Microsoft Word, tak apa. Clearly A. Kalau dia tulis guna pakai apa? Pakai keyboard, computer, it's okay. It's more straightforward because A, B is there. Senang nak recognize. Okay?
Okay, baik. Thank you, Prof.
Okay, this can be, kalau you PK project next year gonna be difficult for data collection. Kita ada ethic lagi. Your ethic is very annoying, you know. Sometimes you just give up because of the ethics. Okay, semua dah ready, ethic tak clear, then it's difficult. So you must have a backup of data set. You ready dengan data set yang dah ada out there. In case you have collect only 10 people sample, then you can plus your existing data set that you download from the internet. I think it's acceptable. You're gonna be pass, not fail. Okay?
Thank you, Prof.
This out there is important lah. You have to look. There are banyak data set. EEG lagi banyak. Tapi bilangannya dengan yang nature driving car tu sikit lah. EEG very sikit lah. Very few people do on EEG kan. EEG is a domain specific yang rare orang ambil. Tak banyak yang orang buat. Kalau intelligent macam object detection, itu semua dah banyak. Face recognition, OCR, optical character recognition, and all itu dah banyak. Okay. Now develop the model. The third one. Now here we choose neural network lah because of our nature. Our course is about compositional neuroscience. So we're gonna use neural network, and the one we choose neural network basically because of not the cost, because neural network is definitely a good one for the future. So you punya timing tu memang kena lah, bukan sebab tak ada alasan saya terpaksa ambil neural network. No, memang you kena ambil neural network. Kalau dalam, if you have other courses pun, not the computational neuroscience, you are forced to use a neural network, even it is not a neural network domain on your master course or whatever. Okay, so this one is training and data set, and so you got the data set here, divided 80% for the training data and 20% for the test data. Okay, normally like this. Kalau kita ada 10, 8 kita masuk untuk training and 2 lagi kita untuk test data. Okay. And assess the performance. It is measuring the accuracy. 80% of bila kita train data, basically we're gonna running the neural network model until 0 is lost. Not until 0 is lost. When the loss is 0, you know, when the target value, you calculate the loss. When the loss achieved to 0, mean that the model is well trained, complete. Okay, so bila dah complete, you just running the data. When you running the data, this is come to the accuracy. When we got test data, we put data, but we don't tell them what is the label. The model gonna predict what is the label, and whatever it predict, if all accurate, then means 100% accurate. So kita ada 10 data, 8 kita dah guna train. Loss will be 0 here. When you train the model, loss will be 0. Then when loss will 0 mean the model is trained. 8 daripada 10. Ambil yang 2 remaining to test. Masukkan without telling the model what is the label. So the model will detect it is a dog, betul. The second data nombor 2, it is a dog juga, betul. So it is 100% accurate. Okay, that's normally assessing the performance. So when it's 100% accurate, your model is accurate. Then your model pass to the programmer, computer science. Hey, I got this model. I approve that the accuracy is 100%. Can you make the application? Nice interface. Can you make a application for me that will be used in handphone, smartphone, and all those things? Okay, because the model is important. Once the model is accurate, then you can make it a commercialization. All right. Okay, let's see the project title, face recognition. Okay. So in this case, software that able to recognize a fish. Okay, I can imagine like cat and dog. Software that want to recognize whether it is a cat or a dog. Okay, so in this case, it's a fish. Okay, so it look like similar. That one is cat and dog. This is a fish. Okay, now that's a problem statement basically. I'm already go to the problem statement. Okay, problem definition. It is similarly like cat and dog, but now you use data set fish. And the question, since fish, we already know the fish, so I don't have any difficulty in understanding the domain of the problem. If the domain is about prosthetic tadi, that's problem lah, because I need to learn prosthetic. I need to learn the domain, and I need to meet you if I have to know more on prosthetic. I think I'll meet the prosthetic hospital, asking a lot, reading a lot, so I got understand. In this case, fish I already know, fine. Then I have to think about this one. What type of project is this? Okay, this is fish recognition. And then what kind of fish I want to identify? Fish, not fish, to label, or fish, ikan haruan, or how many I'm gonna for the label? Haruan, ikan keli, ikan semanggul, ikan sepat, ikan apa. I think I need to limit only 5. Okay. I need to label it only 5. And what type of data? We have text data, we have image, input dia kita, I nak buat apa? It is a text data or image or both. Alright? Once you got the label, saya nak, in this case, I want to produce only 5 type of fish I want to identify. Ikan sepat, ikan haruan, ikan keli, ikan A, ikan B. Okay, ada 5 only label. And then text data or image data. Okay. When you say text data, I'm going to be like bank loan application. When you take images as input, so I'm going to recall it cat and dog. Ada gambar dog and cat, and features going to be pixel. Kalau saya ambil cat, pixel going to be features going to be pixel, where we have 400, 20 kali 20, 400 features. Ataupun saya boleh guna energy, contrast, homogeneity, and satu lagi, 4 sikit saya ambil 4 lah. Okay, that's I decide. I'll take only 4. I take 4 features: energy, homogeneity, contrast, and one more. Okay, so 4. Sebab apa? Sebab mudah, 4 je. Kalau I ambil pixel banyak calculation, because probably time constraint and so on, or budget constraint. So kalau more detail you can have 400 features. So basically the more you got features in general, better. Okay. And how do you collect the data? Fish. Let's say you have selected it as text data. Okay, I put text data. So the label will be 5 ikan keli haruan. Text dia apa? Features dia apa? Size ekor dalam sentimeter, berat dalam kiloji, warna biru, merah, kuning, and so on. Apa lagi? Size mata. That's the features I'm going to choose when we tag. And where do you collect the data? Where do you collect? Where can you have a data? Then this collect data. Basically, I can get download from the internet. Okay. Probably internet pun tak ada data ni, ikan sepat, ikan keli ni tau. Tak ada dah, mana ada ikan sepat, keli punya kat data. Kalau salmon banyak lah kan. Salmon, keli, ikan sepat. Ni masakan kampung memang tak ada orang buat data set ni. So you have to collect yourself. How do you collect your data? This dah masuk second part tau. Okay. Dah masuk second part. So how I collect my data? Oh, that's a real experiment. Tangkap sebanyak mana ikan sepat, ukur dia punya size dia, catat warna dia. Ini ikan sepat. Size dia begini, begini, begini. So how many I need ikan sepat? I need 1,000. Carilah 1,000 ikan sepat. Memang gagal projek ni sebab mana nak dapat ikan sepat 100. Tapi you can just take 20 sample, you can see the pattern and you just can make the data about that. But it's not real experiment. But anyway, it's okay. Okay? So that's the problem definition. Okay, Ifah? Tahimah? So this is the kind of problem you're going to decide when you propose the title of the project. You got a project from somebody else. But in this case, you propose yourself, think about this one. When you clear of this thing and resources are there all, so proceed. If you don't have data outside as a backup, even if you need to collect the data also difficult, seem it is impossible in very time range, so choose other topic. Okay, otherwise going to be problem. And ethics satu lagi. Okay, and how many and so on. And how many, basically when you do supervised learning, you can have 10, 20. Kalau EEG mungkin boleh lah 40, 30 samples, okay, because limited thing, ethic. But like a cat, fish, this is you need 1,000, more than that. Kalau in real deep learning, you got 40 million images. Remember just now my first page, 14 million images with 100 with 1,000 label. Okay, that's big, you know. When you go to deep learning, you need very huge data, about million. The bigger the better. If you got 10, 20 for cat and dog, they simply is not, data set is not sufficient. The project is fail simply because not fail lah, very weak lah. Nak fail pun tak boleh sebab all the methodology is there. Just because of data set is not sufficient, not fail, probably lower rate. Okay. Tapi thesis kita cuma ada pass and fail. It is still pass, but you have to do some correction lah, add more data. Kena buat lah, add more data. So you got how many weeks remainder? 2 weeks, you have put more data and running it. Okay, just to make sure other people read, make reasonable. All right, so this is my data collection. So I'm going to have width and lightness. So I collect 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, now my label is 2. I want to recognize either salmon or sea bass. Only 2 fish I recognize. I decide that salmon or sea bass. And I decide also the features only 2, width and lightness. Lightness is kecerahan dia, warna dia. Okay. So in the lightness apa? Ringan apa? Width lebar. Okay. Lebar ikan tersebut 14 cm. Kalau salmon 14 cm. Dia punya ringan dia, berat dia, okay. 2 gram. Kalau salmon another one 12 cm, 4 gram. So I can download from the internet. Kalau I tak ada dalam internet, I just take any salmon. I kena beli ruler to measure the width, and I have to buy a timbang untuk tahu dia punya weight of the salmon. In this in 4 gram or 4 kg. So I take measurement of all the fish. I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I got 11 fish. And in this case, I need actually banyak lah, 1,000 or 500 at least for this fish. So I measure every fish of this, I put it on this. So this is my data set basically. Okay, I got this data set. Okay, data collection and preparation. And this is 14 centimeter, all are in centimeter, all are in gram or kilogram. Okay, or ounce or whatever. So one metric is also 1 metric, and my label is salmon and sea bass. Okay, so this is my data preparation. Now my develop a neural network model. Remember this flow, you have to follow this flow. Now we are here. Okay, develop a model. So this is the model that I'm going to choose. Okay, so like what you asking just now, can you use existing model? Yes, you can. But here I create my own. Okay, I decide I'm going to use 3 layer of neural network, and target value is salmon or sea bass. So target 1 will be salmon, target 2 will be sea bass. Okay, and I decide I got 2 layer, 2 node cukup lah. Okay, and the second layer 3. So I pick only 1, 2 layer. This is the output label. So I think 3 lah, 3 layer, 1, 2, 3. Why 3 layer? So I can answer, I don't know. I just throw brainstorming. How many do you want? You want to put 4 layer? Okay, fine. Let put 4 layer, and first layer 2, and then somebody you ask why 2? Well, it is the initial value. I don't know yet. We'll see later how is it. If it is 2, okay, then okay. If it is not, I'll put more. Because just like brainstorming, you know, when you design, it's up to you how many layer. 2, okay, then put 2. And then your friend said, no, 2 is too small. Put it 500. Oh, no worry, 500 is okay. We got 500 here. Then second layer, Let's put 1000. Okay, fine. We got 1000. Then finish. Hey, it's too soon. Can we have another 3 layers? Oh, yes, you can. Up to you. You can have 3 layers and more. Okay. And but this you cannot have more because you have only Salmon and sea base. That's specific. And 2 nodes here as output. And then you cannot change. This is fixed because you have Salmon and value. Now the input. The inputs you have. The input you have this number, lightness and width. Features. You only got 2 features. So here must be 2 features. You cannot change. Why 2 features? Can we have 4? No, you cannot have 4 because your data set is 2. If you want to have 4, you have to put another features. Lightness, width, color, size echo, size matter, and so on. So you can have more. Okay, just depend on your data set. Okay, now, okay, let's say I design like this. So this is my model. And this is Salmon, this is sea base, and this is the input width and lightness. Now this is my model. So you have developed your model basically. Okay, by simply saying that you have to develop your model. And hopefully, this model that I developed with 2 layers, first layer, 2 nodes, second layer, 3 nodes. Hopefully this work. Are you sure? I don't know yet. I just make experiment. Hopefully it's work and it can recognize good. Do you think this model 2 layer small one can? I don't know. Probably yes. We'll see the outcome. How is it? If the outcome is not good, I'll change this. My experiment will change 2 to 3, 4, become more layer and so on. Even activation function here. Probably I change it to anything and probably I drop this one. I masa running, I pangkah ni tak boleh jalan, not fire and all those things. So that's the experiment, okay? In order to get the accuracy. Okay, you have developed a neural model now. Now, next section is training. So in how many neurons for you to decide. In this case, I got 2, 3, 7 neuron. Target value in this case, I got 2, Salmon and sea base. How many input? I got 2, lightness and width. What activation function? In this case is a softmax function, and this is could be ReLU and ReLU. Okay, activation function and ReLU. All right. Now, train, testing, and accuracy of the model. This basically you need to. This is basically you need to use a Python language or other any language and execute it. Okay, so this is where you run the model. He will use feed forward, back propagation, look at the loss. Is it 0 or not yet? Not yet. You go backward again. How many times you want to go backward and forward, and how many propagation? What type of initial weight and bias you gonna put it? Which is random or which is other thing? Which is normal distribution or random distribution, and so on. Then you running it until you get 0. Loss is 0. You have to have many epochs. Okay. So this is basically running. Okay. So this one we're not going to do this one because this is the implementation. Okay. We're gonna look at other time basically, but just today we're gonna look at the overall. Okay. So training, testing, and accuracy, you have to use the language and Google use Google Collaboratory. Basically, it's just a text editor. Go to the internet. Okay. It is a cloud-based. Okay, it is a cloud-based. You don't have to install anything. All right. So in this case, all right. This is an example of Google Collaboratory. So you don't have any name project. In this case, I'm gonna put project fish initial. Okay. So IPYNB is basically a Python. Okay. All right. Then here you're gonna write the program basically. Okay. Use the library basically import TensorFlow STF, something like that. Okay. And then you can run. See any if you run it. So this TensorFlow is language of deep learning. The example I want to show you some example, just for your knowledge, how the testing training. Okay, then you have another one. Okay, that's mean when you run, when come out one mean no error. Then you can print and so on, like a programming thing. Okay, print value. Okay, and so on and so on. Okay. Just let's see this one if I got an error. Okay, print 5 and so on. Okay, so this means Google Collaboratory, which is a text editor for you to implement your deep learning. Okay, and you need to sign in. Okay, you need to sign in because it's Google. Basically, it's free. You sign it, then there you are. You don't have to download. And we don't ask this during the exam or test. This is when become the implementation. So for your project, basically, you have to do this. Okay. For our course, I don't ask this on the exam or test because it's become a practical thing. Okay. Okay. It can be assignment or something like that. Okay. And you can explore more. Okay. You can explore more. You run the code. Okay. You run the code. Run all. See the run all. One. Okay. Number 5. Okay. So the run all. What is this? Table of content. Okay. You can learn from here as well. Put new section and those things. Okay. Never mind. Okay. And this is, so once you run time, you execute the code. Basically, it is cloud-based. There is a cloud-based by Google. Google will compile it and give it back to you. Okay. So Google is good. I'm confident with Google. And so I use Google in my project. So do you use Google? If you have to download anything, it's also possible. In this case, I have download. I have instead of Google Collaboratory as my text editor, I use also notebook. Okay. Okay, this I download myself. Okay, so just to show you a bit, just give some view on you. This is not part of the test or exam, just to give you how the training, testing, and accuracy be done. Because this training, testing, and accuracy, you need to implement it and do this experiment. Okay, I use Jupyter. Instead of Google Collaboratory, I use Jupyter. Jupyter Notebook, they call it. Just let's run. How is it? Just hold for a while. Let's see work. This is during training, testing, and accuracy. So I need to do this. Okay. So this is part of the project lah, if you want to do this. Okay. But the easiest way, you use Google Collaboratory. All right. In this case, I've done some project. Okay. Let's say, just let me pull together. Okay, you got cat and dog. Fashion minis. Okay. Okay, let's this one. Okay. So neural network. This is neural network. Okay. All right, this is run already. Okay. Now let's see this one. Where is the data set? Okay, the data set basically, this is a data set that I import. Just basically data fashion. Recognize the fashion, and I got images there. Okay, and I got 10 label. I'm gonna have a label t-shirt, trousers, pullover, dress, coat, sandal, shirt, sneaker, big, and ankle boot. So this is 10. So in your case, you can just use my code to do your project. My code is there already. You just change to dog A, dog B, or dog C, dog D, dog E, and so on. And data set is changed. Gonna be run. Okay. So this is the label I create. And this is sample of the data set, black and white. Okay. And I got how many of them together? I got 60,000, okay, images on my data set. And I got label here. Then move on. This is data preparation. I analyze my data, what it's all about. And this is my weight, basically. You know, get variable, you know, initializer. So this is basically to set the weight. You analyze my weight, okay? And using this, uses Xavier initializer. So let's this handle the value of the variable. And the code is very short. This is where the neural network happen, and so on. And this is where the training happen. Then testing. Okay. Then this is the losses. Okay. So at the beginning, my losses is 3.3. Later on, it become reduce. The loss become almost zero. Back propagation happen until it becomes zero. When it becomes zero, means it's trained already. Okay. And so on. Okay. So this is kind of thing. Okay. It's just to show you. Okay. So I think we're gonna. Okay. So when I close this one, it close everything. Okay. That's some example. Okay. You can use this Google Collaboratory. Copy paste here, we're running the same thing. Okay. Copy paste here. Okay. All right. That's okay. Gets back to our things. Okay. So that's one I use Google Collaboratory. I think that's habis ya. Okay. Tutorial a bit. But I think when you go to do this, you can you ada clue lah. At least project you nak buat dalam next semester, you at least you ada clue. Oh, nampak bayangan. Okay. I got 2-3 more slide here. Just a tutorial. Definite problem tutorial. Find a list of application machine learning around you. Okay. Self-driving car is obvious one. TV, movie, streaming, Netflix. So movie streaming, basically, it goes back to problem definition. Okay. What kind of application do you want to produce? I think movie streaming Netflix is simply the best part is customer, what they like, recommendation, what you want to recommend to the customer based on their behavior of their watching. Okay, just like Facebook, all those things. And I don't know Netflix how they done that. We just simply open Netflix and go to the Netflix, and then we just choose the movie and we watch. And Netflix doesn't connect to Facebook. I think Netflix supposed to be connect to Google or Facebook. This is very good, you know, movie streaming Netflix. When you connect the Netflix to the Google, you can have a profile of each user. Where you connect the Netflix to the Facebook, you can have a profile of the user. They like to watch action movie. Then who is this person? What is name? What is friend look like? What is face? The pattern of the Facebook, you can see are they rich or poor or all those things. So you can, I think that one can be like that. Spotify, I think the same like TV streaming, movie streaming. You have to see the customer, what they really like. I think that's the one I can look for. So basically, problem definition and objective, this application out there is very much. Once you know that you need to learn something, get experience in order to make decision, that is machine learning project, okay? By roughly, in general. Okay. Data set. Find any list data set out there if you know. Or you have a data set yourself from other classes or whatever. So we have a lot of data set out there. Basically, this one is simple, you know. Data set, you just go to Google, okay, and get another one. You just write down EEG data set, okay. I think you can do like that, and you got okay, only free EEG data set, okay. Just look on this, and what are data set out there, okay. Okay, you got mind wandering, psychophysics. You can click on this resting state. Okay, so you can just click on that and you're gonna have a look on data set. Okay, so now look at this data set. It is from GitHub. GitHub is a very important website. Okay, there's a lot of not just only data set, the code itself, like Google Collaborative, as to show you, there's a lot there. So it has been posted 20 days ago. Okay, go to README and you're gonna find. So this 10 data set, I think 10, what is it 10? Okay, 105-minute session of sustained attention of response task with fixed sequence of verifying, okay, and so on. You can have to read this. All right, and studying this and data set is in, look at where is it we can download. That's the most important thing. Okay, I think you see the code there. The code, okay. Okay, download the code. The code is there already. You can just run it. This is what you mean just now your friend asking about existing thing. So when you're running the code, you will see the code, there is a neural network in there running this one. Or probably other things, okay? But the important is now is data set. Where is I can download the data set? Somewhere there, okay? Never mind, you just look at others. Okay. All right. And okay, everyone. Find and list data set out there. Okay. So one of it you can have this. Oh, banyak lagi data set kat sini You boleh check.
Okay.
Kat sini you tengok yang ni pula. Data set apa yang ada. So this backup data set. So you feel secure when you have data set in this kind of supervised learning project. Okay.
Okay.
So you have here is number of attribute 4. 4 means features. Features can be categorical and integer 0, 1, 2. Categorical is categorical is angry, salmon, all those things. Okay. And mana sini ada download lah. Okay. And you can learn more on this thing and look. Okay. Ada paper semua. Tapi yang ni lama. Okay. So too old. 95. So when it old, it's not used lah. Guna yang lain yang lebih terbaru sikit. Okay. Ini apa pula ni? Okay. And so on. Ada banyak lagi you boleh check. Okay. Kalau saya tulis kat sini, tadi saya punya projek tadi fashion. Okay. Katakan fashion. Okay. Okay. Sini. Okay. Oh, ni Kaggle. Kaggle is satu lagi website yang ada banyak simpan. Okay. Macam-macam dataset. Okay, dekat sini saya ada banyak dataset yang saya boleh guna. Ini fashion nampak gayanya ni. Okay. So, ni download dia ada 23 GB punya dataset, banyak, besar. And it is fashion. And image, type the image. Okay. And dia ada 12 kolom. 12 kolom mean kolom menegak kan. Row melintang, menegak mean ada 12 features. Okay. So image dia, you tengok sini. So ini image dia. Oh tak keluar pula. Okay. Mungkin my computer is not compatible. So this is the pictures of the image. JPEG dalam bentuk JPEG. Okay. You boleh download this. So this dataset already. Okay. And so on. Okay. Ni another one. Fashion juga. Okay. So di sini, so you have to explore this kind of thing lah. Okay. Yang basically understand. Ni dataset dia. Okay. So this is fashion. So di sini dia kata Zalando ni adalah company yang collect dataset ni. Okay. Biasanya Zalando ni company yang select yang collect dataset ni. Data preparation. So dia ada 60,000 images. Banyak tu 60,000. You kalau cari 60,000, I think couple of years, you know, and you need people to collect it. When you collect it, you see all the pictures are almost the same pattern. So ini data preparation ni. You have to pick all the, when you take the pictures, you need to have like this kind of thing. You tak boleh sengit gambar tu. So kalau gambar tu sengit dah tak, not, so this is a very rigid data set. Because you cannot have, this is I think example, okay. Kita ada 60,000 sampel of fashion. So ada test set 10,000, training 60,000. So semua jadi 70,000. 60, 70. So like 80-20% ratio. And step image ada 28 kali 28. 28 kali 28 berapa? 28 kali 28. So 28 kali 28 features, pixel, okay? Alright, and pixel. So you can use this data set, masukkan dalam neural network, okay? And you can download the data set already. And ni ada label, ada 10 label. T-shirt, trousers, pullover, ni yang saya guna tadi, okay? So ni loading, ni code dia sudah ada, okay? Code dia dah ada ni, okay? Ini dalam TensorFlow code, okay? And so on. Alright. Okay, next. Okay, untuk dataset, I think see now ada banyak dataset. You just, but in your case tadi lah EEG, okay? EEG tadi is the best thing to start lah. Start with EEG lah. Kalau fashion is not represent the cost. EEG dataset. You can have many EEG dataset about attention, focus, and all those things. Okay. EEG, driving, attention. Attention ke panggil? Cuba try. Okay, kita dah ada ni. Okay, this is 2019. Nature. Nature is a good publication. Okay. So if you look at this, just ini, okay. Ini tahun tak boleh nak buang, okay. This is 2019 baru, okay. So dia punya EEG, dia ada collection of EEG dataset recording sustained attention driving task. So maksudnya driver ni dia pakai EEG capture. Mungkin dia pakai spec ke, kat spec tu boleh capture the EEG. Bila dia mengantuk dia tahulah. They can alert the driver. So the driver behavior and driving academic 90 minutes sustained attention. So yang penting di sini kita tahu dah kita nak cek dataset dia. Okay, sebab kalau kita nak collect your own, it takes time. So we have to back up here. 27 voluntary participant age 20 to 28. So this is how it done. And it's put in the Nature, you know, Nature publication. Nature is, you remember just now ada Lee Sedol yang kalah dengan computer science tadi? Game is masuk dalam Nature punya journal. Nature journal is very high. Okay, very high. Alright. So apa lagi ada EEG driving? You can type anything, okay? Then you can start project your things, okay? And tutorial 3, deep learning architecture. How many neural network are there on the okay? So you just deep learning is the same thing with neural network. You just like this, okay? So let's put images. Ada banyak, okay, jenis. Ni yang simple one, okay? Just a few nodes. This is more complicated. Ada banyak nodes ni. Okay, cuba buka. Okay, so this is one architecture. Okay, one architecture. It's up to you. So this is another architecture. What you call it? I can't remember. There is a name on this. Okay, there is a name. Okay, so ada banyak jenis architecture you can have. Say Inception. Ini Inception ni nama juga, okay. One specific VGG is another architecture of neural network. So ni, okay. Oh, banyak ah. Alright. So kita ada guna softmax and so on. So ini image dia bagi 28 kali 28 pixel become slower, and this is where neural network happen. Okay. So this is one architecture. We call it VGG. Stand for what lah? Can't remember. Ingat tapi lupa dah ni. Okay. So this is one architecture. Ada banyak architecture. Basically. The one we learn is a simple one, neural network. Okay. But once you know the neural network, the others is easily. Mudah saja. Alright. And ResNet. ResNet is another one architecture juga. ResNet macam mana rupa bentuk dia? Ni tengok ResNet, okay. Alright, something like this, okay. Ada banyak lagi, okay. Alright, there's architecture, banyak architecture you can find out there. You can use it, but here you can just simply use a neural network layer and very basic one. And tutorial 4. Ni you buat kat rumah, okay. I got this data, build application for this. Or this one. So iris data the same, iris data recognition, bunga, so jenis flower. This is a data I have. So, and this is also another flower iris data, but now is flower. Okay, I think that's all. Okay, yeah, semua?